All right, so if we actually go plot our points then, was there anything here to make this thing flip? Is this going to be exponential growth or decay? The base is bigger than 1. X is positive. This baby's growing. So it's normal going up to the right. So all you have to do is plot these points. 0, 1, 1 over, whoa, what did I just do wrong? Yes, our origin's down there. So yeah, I should be doing 0, 1 down here. So then 1 over 4 up, what do you think? Will I get 16 on? I will, because I rigged this problem to drop really low. That's why we went -8. So I know it's 8 up to the x-axis, and then I need another 8. 2, 4, 6, 8. That would be 16 up. Okay. So is this one going to have much bend to it? No, this is a pretty sharp turn. This baby grows fast. And then it goes out, follows the asymptote. Just don't curve away from your asymptote. That's all I ask. Okay. That's pretty steep, and that's only a base of 4. Imagine if I did a base 10. I'd be at 110. What would be the next point? 100. Because 2 would be 10 squared. So you on the second 2 over, and you'd have to be 100 up. Okay, so you gotta understand exponential functions grow extremely fast. So when we get to any kind of numbers like that, we're throwing in a calculator, because you aren't going to plot that by hand. It's not going to happen. So, okay, that wasn't too bad. You're going, I'm bored, should it challenge me? I need to graph something more challenging. Oh, this isn't that challenging, but I do want to check. It's the same thing as what we learned last chapter. What are you going to do? You know it's going to flip. I threw a negative on it. So my question to you is, which way is it shifting? Is it going right to or left to?
Well, you're going to be switching it with the negative. Like instead of 1 over 3, would it be x and then the negative 2?
Yeah. Or basically what you need to do, just like we did with those square roots of 6 minus x, I pulled the negative out and made it become x minus 6. You do the same thing here. If I pull a negative out of this thing, x becomes positive, 2 becomes negative. So you've got to get the negative pulled out front. So now is it going right to or left to? It's going right to, yeah. Since that's a -2, this baby's going right to. Is it going up or down any? Any number added on the back? Nope. So it's not. We are just going to go right to, so we're just shifting over just a little bit. And I'm going to immediately put my asymptote on there, which is still on the x-axis then. Okay, so how do I get a t-table of points to plot? What should I do? What points should... 0, 1, 2. Probably not going to do 3 because it's going to get too big. And so I'm doing 3 to the... Remember, when you go to plot it, you've already shifted it. The negative we know is going to flip it. When you go to plot these, all you are plotting is the base to the x power. You do not have to do anything else. Just the base to that power. Plot your points. So 3 to the first is going to be 3. Oh yeah, that's 3 to 0. Thank you. I didn't finish writing. That would be 1, yes. And 3 to the second power is going to be 9. If I went to 3 cubed, I would have 27. I don't want to count 27 boxes, so I'm not going that high. So I know those are the points I'm going to plot. The question is, does this thing rise to the right? Is it flipped? Is it going up on the left side? Yeah. Since it's got the negative on the x, this is exponential decay. It's coming down. So when you plot, your 0, 1's fine. But when you do the 1, 3, you want to do it on the left side because we want it to actually come down. The 2 over from our origin is 9 up. That's on the left side, and then this baby can drop toward the asymptote. coming down. There is one other flip that can happen. I'm not going to do a major one of it, but I want to ask you about it. What if they do this to you? What if they put a negative out in front of the whole exponential function? You can't have the base number be negative, but you can throw a negative clear to the front and put it in parentheses. So what does a negative in front do to every graph we ever draw? Flips it upside down. So in this case, a normal exponential function is growing. What happens if I flip that one upside down? So this point, I always think about this point is 0, 1. If I flip it upside down, it's down here at 0, -1. Okay. It's got, if it was curving up here, then it's got to curve down. It's got to curve away. The part that was following the asymptote is still going to follow the asymptote. It's just on the other side of it. So if there was a negative out front, this thing would be curving away and down from you somewhere. That's less common. The one up here with a negative x, way more common, exponential decay. You see that plot? It's got a friend. Woo! Are we having fun yet? This side of the room over here is worrying me. Are we all awake and alive in there? Okay. So, you're going, golly gee, did we get to solve equations with these? And of course the answer would be yes, we get to solve equations. So, what would an exponential equation look like? My variables have to be in the exponent. I stapled my papers out of order, so I'm having difficulty. So, this is what you might see in an exponential equation. You have to solve for x, but x is up there in the exponent. Well, how can you do algebra and solve for x when it's up there? It's not like you can add numbers from one side to the other. I can't go add the x over, subtract the 3 to the other side. They're up there in the exponent. That's not legal. So, what on earth are we going to do? Well, what you have to do is you have to get the base numbers somehow with some smart algebra. You have to get the base numbers to become the same number. Okay. And you're going to have to rewrite one or both of them as some number to a power. Okay. What do y'all know about 121? It's 11 squared, isn't it? So if I changed it to 11 squared, I have to keep the 3 minus x on the outside. This has got a base of 11. I would have changed them both into problems that have the same base. So that's the first thing you're always going to do. The key to these is to make common bases. You're going to hear me say that a whole bunch of times in this chapter. Okay. So then now, rules of exponents, what do I do with this 2 with a 3 minus x on the outside? You multiply we know we multiply exponents there, so that would become 6 minus 2x. This is the cool part. It says these two sides are equal. Do you all agree with that? The two sides are equal. It's telling us that. It's saying this side equals this side. The bases are equal, aren't they? So therefore, what should be true of the exponent? The exponent should be equal too. So therefore, once you get it to have the same base number, you can drop the bases off, and you can just set the exponents equal and say, well, now I know 2x plus 3 has to equal 6 minus 2x. You just get to drop the bases completely and solve for x. Just normal, ordinary solve for x. So I would be adding 2x and subtracting 3, which means I'm going to get 4x equals 3, which means x equals what? 3/4. Now, would you have guessed that looking at that problem? These are not exactly ones that are easy to guesstimate what the answer is going to be when you're guessing the answer for an exponent. But yeah, turns out if we put 3/4 in for both those x's and punch that in our calculator, they would come out equal. Isn't that cool? Looks exciting. It's like fascinating. It works. But once again, I'm boring you. I'm not challenging you. You need more. You're going, at least let me use the rules I learned in the last chapter so I can expand my mind and keep retaining those wonderful things. So let's do one with a touch more pizzazz to it. We have a 1/9 and a 27 as bases. You got to think, what number could I rewrite them to? I usually, first I look at it and go, which is the smaller number? The 9. Is there 9 to a power that makes 27? No, not to a nice full number power. Okay, if that happens, you can't do 9 to a power and get 27, then that means you've got to change both of these to a smaller base. You'll always make them a smaller base. You cannot make them bigger. So what number could I rewrite both of them as that number to a power? 3, wouldn't it be? So I could say 1/9 is really 3 squared, and I could rewrite 27 as 3 to the 3rd. This is why you may find your pink sheet still helpful. Now, you can't drop the bases yet. Everything has to be up top first before we drop bases. So I got to get this 3 off the bottom of the fraction. How can I bring it up? Yeah, it's negative 2 power with a 4x on it. And then while I'm at it, yeah, what can I do now that both of them have a power with another power on the outside? That's a 2, not a 3. Now our rules of exponents say you can multiply them. So that'd be negative 8x. Here we'd have to distribute and get 3x plus 6. Once you're at that point, you have to be that clean. You're down to 3 on both sides of the base. What can you do? Yeah, drop the bases, set the exponents equal. So negative 8x equals 3x plus 6. And now it's going to be simple, easy, normal solving for x stuff. Okay, which way do you want to move the x's? Move the 3x? You're going to have to divide by, we're going to end up negative either way we go, so this one really doesn't matter. So if I would bring the 3 over, I'd have to subtract it, which would give me negative 11, and I leave the 6 there. So then I'd be dividing by a negative 11. So that's my somewhat ugly answer. Negative 611 is the number that makes this equation true. It makes both sides equal. Now, this process right here of taking, changing, and making common bases, that's going to be the bottom step of some of Friday's logarithm problems. You'll do something with the logarithms, you'll get to this point, then you have to make common bases. Oh goodies, yeah! Okay. We're comfortable with this or not? I have just one question for you that goes with this. Or we'll just rewrite this first part. What would you do if I gave you a root in the problem? We'll just start this one, we won't necessarily finish it, but how would you start that? That's 4 to the x. Okay. You could cube both sides. I'm a little leery of telling you that because there's lots of room to make error doing that. How can you rewrite a root as a power? It turns to a fraction, doesn't it? So yeah, we'll be able to turn that to a fraction. However, I would recommend first we got to find the common base. And once again, look at the small one. Is there 4 to a power that makes 8? No. So that means you got to rewrite both of them. So what's a smaller number they both can go to? 2, yeah. So this would have to actually be 2 squared, so that would make it 2 to the 2x. That would be 1 over 2 cubed. So now where do I go with it? There you go. That would be 2x over 3. It would be a fraction. What do I do with this 2? It's got to come up. So yes, it's 2 to the negative 3 with a 5 minus x on the outside. And then you could go ahead and distribute here and multiply those powers together, so we'll have negative 15 and positive 3x. Then what can you do once you get to that point? Then you can set them equal and solve it. This would be the easy part. Yeah, I guess we might as well finish it since we came that far. So yeah, we would times it by 3, which would give us 2x equals negative 45 plus 9x. Yeah, kind of big numbers. I didn't use that. So yeah, if I was me, you all want to move the 9 or you want to move the 45? If you move the 9, you're going to get negative 7x equals negative 45, which means when I divide it, what's going to happen with the negatives? They're going to cancel, and I'm going to get 45/7. That's solving exponential equations. Okay, the book has really weeny ones, so I wrote you more exciting ones on this other sheet. You should all say, thanks, Mrs. Meyer. That was really generous of you. I'm sorry, we are not weenie mathematicians. I should stop it.